All right, in this video, what I want to do is I want to talk about inverses and specifically determinants of inverses. And so, of course, we'll know by now that if you have, say, A is an n by n matrix, it doesn't really matter what the size of that is, but let's say A is an n by n matrix. Then we know that if we take A times the A inverse of A, we get the n by n identity, which is the diagonal matrix with ones all along the main diagonal. And we also have seen a few things. So first of all, we know that the determinant of the identity matrix is just the product of all the terms on any diagonal matrix. The determinant will be the product of the terms on the diagonal. In our case, the determinant of the identity matrix will be 1. We also know that if we were to take the determinant of both sides, so we just said that the right side is really just 1. Okay, so that implies that. But also we know that if we take the determinant of a product, that's the product of the determinants. So we can write this as the determinant of A times the determinant of A inverse equals 1. And in fact, you can check that, well, if we divide both sides by the determinant of A, this tells us that we have a formula for the determinant of A inverse, and that's going to be 1 over the determinant of A. One more piece of evidence that really hints to us that if the determinant of A is 0, we're going to have problems with the inverse. Okay, so that's again a nice quantitative way to make that connection. Let's do a quick example. So let's look at the matrix A, which is going to be, say, 1, 2, 3, 4. I'm not feeling particularly creative, but that's fine. And what we can do is we can compute the inverse. And so remember, to compute the inverse, what you do is you find the determinant of A. In our case, the determinant of A is going to be -2, so 4 minus 6. And A inverse is going to be 1 over -2 times, what we do is we reverse the role of, so we're going to reverse the role of 1 and 4, so it'll be 4, 1, and then we make the other terms negative. Okay, and so this is -1/2 times that matrix. That really means that our inverse is going to be -2, +1, +3/2, -1/2. So that's our inverse. And it might be worth just checking if you take A times A inverse, this really is the right inverse matrix. So -2, 1, 3/2, -1/2. And it's easy to tell that the off-diagonal elements are 0, right? Because we get 1 plus 2 times -1/2. So 1 minus 1, and then likewise, -6 plus 6. And then for the diagonal elements, we're going to end up with -2 plus 3 and 3 minus 2. And so we really do end up with the identity. So here, there's our inverse. And then our final step, let's just make a little bit of room. Our final step is let's figure out what's the determinant of A inverse. And we'll just do this the usual way. So we'll take the product of those two terms, so that's -2 times -1/2, minus the product of the other two terms, so 3/2 times 1. And that's going to be, let's see, 1 minus 3/2. So we really do get -1/2. Okay, everything is good. All right.